Hey everyone, unfortunately I can't show you me fixing this, but what I can show you is how I fixed it. And I thought, yeah, should I do a video? Yeah, why not? There's a lot of people out there with this problem, and this may very well help them as well. Now, it is a bit tricky. You do need some tweezers and a fine tip solder iron, um, but maybe even a hot air gun. Well, you could do this job without all that, but I'll show you what needs to be done. Now this is the module that sits under the passenger seat, and it controls the spoiler up, down, and automatic movement. The problem with this was that it was going up and staying up. You turn the key on, spoiler goes up and stays up. You can't lower it. Thought it was this, but no, it's not this. I think this could have that effect, but you're probably more likely to have no up action or no down action out of this module, or maybe no speed control, but not running it up by itself. Well, that could happen if the relay inside was stuck on. There's two relays in here, one for up, one for down. In this instance, it wasn't this module. There is another module. It looks like a relay, so don't be confused and go plugging in a relay. And it sits under the seat right beside that. Now, I don't even know what this is supposed to do, other than maybe it's a fail-safe to try and prevent up and down happening at the same time. I'm really not entirely sure. I thought this might have been the speed control module, but I've since read that apparently pin 12 of this thing has the speed signal going into it. So this has power, ground, and connections to the same line that goes to the up or down switch in the cab. And then this pin that runs off to an unknown position, I don't know where it goes. I can't find a wiring diagram that shows where that wire goes, but I've looked a little bit. I can't say I've looked really, really hard, but I had a look. But anyway, but the operation, at least the manual operation, still worked with this unplugged. But with this plugged in, it was faulting and putting 12 volts out this pin here, which was activating the up signal, and it was always there, so the wing just went up and stayed up, and you couldn't get it back down. So I'm going to go over this, and I mean, if you have the same problem of it going up and staying up, and or maybe even going down and staying down, if it faulted a different way, it could do that. It's got access to both wires. Unplug this from under the seat and see if the thing works normally again, and then you'll have a quick idea that the problem's in here. To open it, you just need to get, it's like most relays, a similar way of opening it, just get something thin and flat and stick it down the side and pry it, and it'll pop. You can see there's a little groove there, because that's where the case clips over the side. So you just pry that out and pop that side up and pop that side up, then you can get that out. Right, I'll show you the top side, why not? Okay, here we go, and that is the connector. That's where it comes in on. The pins are divided up accordingly. It's very easy to see where they connect to on the board. And we have a couple of diodes. The one on the left is our 12 volt in, comes in through there, our battery. The one on the right is the input from the down button. The one at the very bottom is the input for the up button. Then we just have a couple of other components. So let's get it mounted so I don't have to hang on to it. Let's give you a tour of the board coming down from the bottom. Now, so starting at the bottom, we have the pin, that pin there. That's our 12 volts in. This one over the side is our ground, and they can be connected to these pins here. So we've got ground plus 12. From the plus 12, it heads up through this is the diode on the other side, through this relay, through this transistor. So when this transistor gets turned on, now this is a PNP transistor, so we need a negative, more negative voltage than the collector on the base, and it will pass through here. So it'll pass through here, and this transistor was being turned on. So for an unknown reason, it was being turned on. So that was feeding back down here through this resistor and out to the up position wire back to the switch in the cab. That one there is turned on by this transistor here. This transistor is turned on by this IC up the top. So I don't know what all the rest of it is doing, as far as it's some sort of logic, I guess, to decide what to do, when to do it, and so forth. As it stands, so right off the bat you can see I've made a modification here, and I'll tell you exactly what failed. This IC is known as a hex, which means 6 of Schmidt trigger, inverted Schmidt triggers. So a Schmidt trigger is a logic gate that if you have a rising voltage and you want it to, and you actually want an output to be, instantaneously on but not rising, once it hits a certain point as it rises up, then the output of the Schmidt trigger will turn on and give you that nice sharp clean on signal, good for noisy signals and whatnot. And then once it comes back down and hits a certain threshold, the output will drop sharply and give you a nice sharp square wave on off effectively. This is an HEF40106BT. We have our ground pin here, we have B plus over here, and it's currently running at 8 volts with a 12 volt input. This chip's good to 15 volts, I think. Pin 1 is an input, 2 is an output, 1 is an input, 2 is an output, 1 is an input, 2 is an output. These are all separate logic gates, they're unaffected by any of the other pins. What I was finding was that the transistor here is being turned on by one of the outputs of our chip, and that was pin 4. Comes back under the IC, down through this resistor, and that scoots off to our transistor base pin. So that pin was high, which was turning that transistor on, and I was thinking, well, should it be? How do we prove the operation of this IC? Going down the line with your voltmeter, obviously your black lead on ground, red lead on each pin, I found we had 0 volts, which meant we should have 8 volts because it's an inverting Schmidt trigger. So if you have 0 there, you get 1 or 8 volts out, or whatever your VCC is. And if it's a non-inverting, then if you had 0 volts here, you get 0 volts out. The output is opposite to the input. So I had 0, and I had, well, actually I had about 4 volts. And then I had that same 4 volts. Now that 4 volts came through this diode. It looks like a transistor, but it's just got a single diode, anode, cathode here, and then those two pads are joined together. So it's effectively just the voltage is flowing through here and out here, and it stops backfeeding to that pin by having a diode there, if that would ever likely happen. So that 4 volts came through the diode, it comes down through this resistor here to here, down to this resistor to here, and out to pin 3. Pin 3 having around 4 volts, or give or take, once it had gone through the diode and the resistors, was seen as a low. Pin 4 went high. It inverted. So we had a positive 8 volts coming out here and coming down through to our transistor, turning it on and giving us our up signal at the pin below. Now I thought 4 volts was kind of strange. I did some playing around, I changed the diode. I thought maybe the diode measured okay, but under voltage maybe it was breaking down and overloading the output and what have you, and in the end, so like me, most of you probably don't have one of these chips floating around to just drop in. I was probing around and I stumbled across the fact that this pin, which is 1, 2, 3, 4, 5, pin 5 is connected to ground, and pin 6 is floating, not connected to anything. So I thought, okay, maybe there's a chance this chip's faulty and it's not able to drive this output to the full voltage, because it was floating around 4, which was giving us effectively a low. So what I did is I lifted this pin off the board, and I lifted this pin off the board, and I've connected this, which is an input, back to pin 1, which was the input for the first gate, and I connected the output back through to our diode. Now with this pin lifted, it's no longer connected to this point, so it doesn't matter. And right away it worked absolutely fine. We now have a solid 8 volts coming out of here rather than about 4 that we were getting, and that is coming back through here with 8 volts on pin 3. We're getting 0 inverted signal on pin 4. So our transistor's staying off and we are no longer getting our up signal output down the bottom. This may be a common failure. I mean, the car's 1990, so that's getting on a bit, but if these chips are all that old now, they could all very well be failing in a similar fashion. So hopefully that gives you guys something to look for. If you've got that low voltage on pin 2, then yeah, it should be solid like 8 volts or 0. It should not be fluctuating. Of course, if you go up the other side with your voltmeter, it was you know, out in, and the outputs were offset from the inputs as they should be. Nice and good on that side. I think another one of these is also, I think this one here is also unused, so you'd have to remove the join there and separate that leg from your B plus and feed it back. So if you don't have a chip, you can certainly use a logic gate that's not already being used. I have done that before in a completely different device. I can't remember what it was, but I do remember doing it. So I hope that helps you guys with your Porsche automatic spoiler control issues, and who knows, maybe it'll save you $1 or $2. Keep these things on the road. Thanks for watching.